Okay, guys, I'm back. We have one more lecture or one more little video for you to watch, or I have one more little video for you to watch about chapter 9. And this time what I'm going to do is I'm going to walk you through an actual molarity problem. And this turns out this is actually one of the problems for your homework. So this will help you get your homework done this week as well. So without any further ado, I'm going to share my screen and pull up our document, and we're going to jump right in. Okay, so here is the problem that you've been asked to solve. Problem number 14 says a chemist wants to make calcium hydroxide. If a student uses 167.4 milliliters of a 1.39 molar solution of sodium hydroxide and excess cobalt chloride, how many grams of cobalt hydroxide will be formed? Now, a couple things I want you to see. They've given you information about sodium hydroxide. They've given you molarity and they've given you volume. Okay, we have two measurements of sodium hydroxide, but I've been asked to find information about cobalt hydroxide. So I want you to see that there's two different steps and processes we're going to use to solve this problem. The first thing we're going to do is we're going to use the molarity equation, but we also are going to use stoichiometry because I've asked you for information. I've been given information about one substance, but asked for information about a different substance. So here's our process. Okay, so we're going to use the molarity equation to find moles of sodium hydroxide, and we can easily do that because we've been given the molarity and we've been given the volume. So we can use that molarity equation to find moles of sodium hydroxide. Once we have moles of sodium hydroxide, we're going to use stoichiometry to go from moles of sodium hydroxide to moles of cobalt hydroxide. We can just use stoichiometry to do that. That's easy. You know how to do that. And then finally, once I know how many moles of cobalt hydroxide I have, using the mole concept, molar mass, I can go from moles of cobalt hydroxide to grams of cobalt hydroxide. So that is the process. All right, so here we go. Let's jump in. Okay. The equation for molarity is that molarity equals the number of moles divided by the number of liters. Rearranging this equation to solve for moles, multiplying both sides by the volume, the number of liters, I get that the number of moles equals the molarity times the number of liters. Okay, so I'm going to take my 1.39 molarity I've been given of sodium hydroxide and the volume 0.1674 liters of sodium hydroxide, and I find that I have the number of moles of sodium hydroxide is 0.233. Just multiply these two things together, 3 sig figs. Okay, so then we go on to our next step, and our next step says I need to use stoichiometry to go from moles of sodium hydroxide to moles of cobalt hydroxide. So let's do that. I know that if I start with 2 moles of sodium hydroxide, for every 2 moles I start with, I will only produce 1 mole of cobalt hydroxide. So the equation to convert that looks like this: 0.233 moles divided by 2, I get 0.117 moles of cobalt hydroxide. Okay, that is using stoichiometry. Okay, then the third step would be to convert that cobalt hydroxide from moles back into grams. And of course, I have to figure out the molar mass of cobalt hydroxide. Let's look at that for just a quick minute. I have 1 atom of cobalt, it's 58.93. I've got 2 atoms of oxygen, 2 each is 16.00 grams or per mole. And then same thing, 2 moles of hydrogen in 1 molecule, or 1 mole of it. So I'd have 2 times 1.01 or 2.02 grams of hydrogen, which gives me a total mass of 92.95 grams per mole of cobalt hydroxide. Okay, so that's our molar mass. So then I can take my 0.117 moles of cobalt hydroxide that I calculated right up here, use the molar mass, 92.95 grams, and I learned that I would make 10.9 grams of cobalt hydroxide. That's our final answer. The student will make 10.9 grams of cobalt hydroxide, having started with that initial conditions and substances of a sodium hydroxide. So there you go. That is how you would do problem number 14. That's the process you're going to use to solve these types of problems. Okay, and it's just one step at a time. Just know if you're given information about one substance but asked to find information about another substance, you're absolutely going to have to use stoichiometry to do that. So hopefully this is helpful, and I will see you next time. Bye.